Hello and welcome to our physical sciences session. My name is Themba Ncube. Today we are focusing our attention on a very important part of stoichiometry, which will be focusing on the limiting reagents as well as the percentage purity in the context of a chemical change or a chemical reaction. So that's what we're going to be doing for today. Now, let's look at the broader picture in as far as how limiting reagents actually fit into the broader quantitative aspects of chemical change. We want to also recognize that this still forms a part of stoichiometry, but our attention for this session will be on limiting reagents. Okay, so this is what it's all about. And remember, the mole becomes the SI unit of quantity of matter. So we'll talk a lot about the mole in terms of the balanced equations of reaction, but we also want to determine as to what exactly informs or determines the maximum amount of product that is formed based on the quantities of the reactants. As a result, we are saying this is about the quantitative aspects of a chemical reaction. Right. Now, these are the thoughts that are going to guide our discussion for today. Okay. The first question that we put is that what causes a reaction to reach completion? Okay, so when we talk about completion of a chemical reaction, is that as long as there is still a sufficient amount of reacting particles, the reaction will continue. Okay, so this is typically for a reaction that goes from left to right, from the products to the reactants in one direction. So when the reaction reaches completion, what is it that actually causes a reaction to reach that stage in as far as completion is concerned? So that's the big question that we want to put from the onset. So then again, the second one says, what determines the maximum amount of products in a chemical reaction? Okay, right. So those are the two questions. What are some of the keywords? Reactant, products, limiting reagent. When we say something is in excess, what exactly are we talking about? We also talk about the yield in terms of the product. So these two terms, they are actually related to each other. So if one substance is a limiting reagent, if one reactant is a limiting reagent, the other one must be in excess. So these are some of the key terms that we're going to focus our attention on. And on that note, we also want to put it out that, from the beginning that, the definitions, they form, an integral part of our scientific language. So us understanding the key words in a definition and using them correctly in context, I think it guarantees us, our full marks, because every long question will, one way or the other, carry a definition type of a problem, right? Okay, now let's talk about something that we already know by this point. We're saying that the mole ratios in balanced equations. So everything is about the mole, which is the SI unit of quantity of matter, right? So in terms of quantity, or in terms of quantitative aspects of a reaction, we talk about the mole ratios. So a balanced equation of reaction actually tells us that this is the stoichiometric ratio, in which substances actually react with each other. So for us to quantify reactants and products, we have to talk to actually draw our attention to the balanced equation of reaction, which has a lot to do with the law of conservation of mass, right? Okay, and again, we also want to appreciate that the balanced equation of reaction is an indicator of the stoichiometric ratio. So the stoichiometric ratio in which substances react is actually, the whole number ratio in which these substances participate in a chemical change, which forms new substances, which are the products, right? And so when balancing the equation, we apply the law of conservation of mass. Okay, so if for argument's sake we consider a reaction that is simple hydrogen and chlorine gas to form hydrogen chloride, the stoichiometric ratio is 1:1:2. It means a mole of hydrogen reacts with 1 mole of chlorine to form 2 moles. So if we put this in terms of quantities or in terms of mass, we can say in 2 grams there is a mole of hydrogen. in 71 grams, there's a mole of chlorine, and so on. So this is the interpretation of the stoichiometric ratio in which substances react. Okay, so when substances react in any chemical reaction, when we talk about the limiting reagent now, okay, they do not necessarily react in exact amount that all reactants get used up. So in a way or the other, one of the reactants usually gets used up or exhausted, and then the other one remains. So that which remains is actually the one in excess. But the reactants that get used up is what would refer to the limiting reagent, which will actually determine the amount of the product, right? So this is what we want to appreciate also, that the ones that are not completely used up, they are in excess, right? And then also, as you know, that the limiting reagent can be used to determine the theoretical amount of the product formed. So that's the main idea in as far as the reagent is concerned, right? Now, I would quickly go to a simulation that would actually show us exactly what we mean when we talk of, you know, substances being in excess and the other reactant being, you know, a limiting reagent. Let's say, for argument's sake, a reaction between hydrogen and oxygen. If we've got 1 mole of that and 1 molecule of oxygen, you'd realize that there is no water that is formed. So unless we put a certain number of, you know, hydrogen molecules, there are 2 products, 2 units of the products that are formed. So you'd understand that, but if we had 1 of each, there is no product that forms. So this speaks to the stoichiometric ratio in which they react. How about if we put 4 of these and let's say 2 of the oxygen? Okay, so the ratio still stands. It's 2:1:2. Because if you say 4:2:4, it's the same as the stoichiometric ratio in which they react with each other. So this is a typical example of what exactly it means when we say substances actually react in fixed ratios, right? So that's the main idea in as far as the stoichiometric ratio is concerned, right? Okay, so that's the whole idea in as far as, you know, the issue of limiting reagent as well as the reagent that is in excess. For now, we'll take a short break, and then when we come back, we'll look at questions that have to do with the limiting reagents in a chemical reaction. Let's take a short break for now.